You are welcome to my class. In this video, we'll be solving questions on concepts related to elastic properties of solid, such as strain, stress, and Young modulus. So let's have our first question. The tendon in a man's leg is 0.1 meter. So this is a man's leg. So the length of the tendon in a man's leg is 0.01 meter. So let's assume that this is the tendon. So the length of this tendon is 0.01 meter. If a force of 5 newtons stretches the tendon by 2 times 10 raised to power minus 5, that is, if the length of the tendon increased by, if the length of the tendon now increased by 2 times 10 raised to power minus 5, when a force of 5 Newton applied on this tendon, so the length increased by 2 times 10 raised to power minus 5. Calculate the strain of the muscle. So let's recall that strain equal to extension divided by the original length of an elastic material. So this extension equal to change in length, that is the final length minus the original length of an elastic material divided by the original length. So when extension is not given, so use change in length divided by the original length of the elastic material. So let's come back to this place. 0.01 is the original length of this tendon. So the original length of the tendon is 0.01. So let's call it L. L equal to 0.01 meter. But there is an increase in length. There is an increase in length by 2 times 10 raised to power minus 5. So increase in length is the same thing as extension. Extension equal to increase in length. So therefore, E equal to 2 times 10 raised to power minus 5 meters. So E is extension, that is change in length. So from here now we can calculate strain. So strain will now be equal to, so our extension, which is 2 times 10 raised to power minus 5 meter, then divided by the original length of the tendon, which is 0.01 meter. So meter we cancel meter. So no unit for strain. So which is equal to 2 times 10 raised to power minus 5. 2 times 10 raised to power minus 5 divided by the original length of the tendon. So 2 times 10 raised to power minus 5 divided by 0.01 will give us 0.002. 0.002. So we can convert it to standard form. So when you convert it to standard form, it will give us 2 times 10 raised to power 1, 2, 3. So 10 raised to power minus 3. So the strain, our strain equal to 2 times 10 raised to power minus 3. It says if the stress of a wire is 10 raised to power 7 Newton per meter square, if the stress equal to 10 raised to power 7 Newton per meter square, and the wire is stretched from its original length of 10 centimeter. The original length of the wire equal to 10 centimeter. So let's call it L1 equal to 10 centimeter. So to convert this 10 centimeter to meter, we are going to divide it by 100. So 10 divided by 100 will give us 0.1 meter. So to convert it to meter, then the wire stretched to 10.05 centimeter. So let's call this 10.05 the final length, L2 equal to 10.05 centimeter. So let's convert it to meter. So that will be 10.05 divided by 100. So it will give us 0.1005 meter. The Young modulus of the wire is, so we are looking for the Young modulus of the wire. So Young modulus is denoted by something in form of Y. So which is equal to the ratio of the stress to the strain. So they've given us the value for the stress. So we are looking for the strain. So there's nothing like strain in the parameters given. So we have to look for strain. So strain equal to change in length L2 minus L1 divided by the original length of the wire. So which is equal to this change in length, that is L2 minus L1 equal to extension, then divided by the original length of the wire. So we have to look for extension. So E equal to change in length, that is L2 minus L1. So which is equal to, so what is our L2? L2 equal to is 0.1005 is 0.1005 minus, so L1 equal to 0.1 minus 0.1. So extension will be equal to is 0.0005 meter. Is 0.005 meter. That is our extension. So to calculate strain, strain will be equal to our extension E, which is 0.0005 divided by the original length of the wire. So what is the original length? That is our L1. So our L1 equal to 0.1 divided by 0.1. So strain will then be equal to, so is 0.005 divided by 0.1 will give us 0.005. No units, because our extension is in meter, then the original length is also in meter. So meter cancel meter. So it will give us 0.005. So let's come back to Young modulus. So Young modulus equal to the stress. So what is stress? That is 10 raised to power 7 divided by the strain. So strain equal to is 0.005. Is 0.005. So which is equal to, so by the time you divide 10 raised to power 7 by is 0.005, you are going to get 2 times 10 raised to power 9. So 2 times 10 raised to power 9 what? Newton per meter square. So this is Young modulus. So Young modulus equal to 2 times 10 raised to power 9 Newton per meter square. So the correct option is what? Is D plus. A wire of length 5 meter. A wire of length 5 meter. The length of the wire equal to 5 meter. And diameter of 2 millimeter. Diameter D equal to 2 millimeter. Extends by 0.25 millimeter. That is, the wire increase in length by 0.25 millimeter. Then increase in length is equivalent to extension. So therefore, extension equal to 0.25 millimeter. When a force of 15 Newton was used to stretch it from its end. So force equal to 50 Newton. Calculate the stress of the wire. So we are looking for the stress. 1. So stress is unknown. B. The strain in the wire. So strain is also unknown. Then take pi equal to 3.142. Pi equal to 3.142. So the first question, we are looking for the what? The stress. Stress equal to the force applied on an elastic material per unit cross-sectional area of the material. So when the cross-sectional area is not given, so you use force divided by pi r squared. So cross-sectional area equal to pi r squared. So let's come back to this place. F equal to 50 Newton, but there is no value for cross-sectional area from the parameters given. Then they've given us the pi equal to 3.142, but no value for radius. But we can get radius from diameter. Diameter equal to 2 millimeter. So we have to convert this diameter to meter. So which is equal to 2 divided by 1000. So equal to 0.002 meter. So value for diameter equal to 0.002 meter. So to get radius is equal to diameter divided by 2. Then diameter equal to 0.002, then divided by 2. So it will give us 0.001 meter. So the value for radius equal to 0.001 meter. So from there now we can calculate stress. So stress equal to force divided by pi r squared. So which is equal to F equal to 50 Newton. That is 50 divided by pi equal to 3.142. So they've given us the value for pi, 3.142. 3.142 multiplied by, then radius equal to 0.001. 0.001, then to the power of 2. So equal to 50 divided by 3.142. 3.142 multiplied by 0.001 to the power of 2 will give us 0.00001. So therefore, stress will be equal to 50 divided by 3.142 multiplied by 0.0001 will give us 0.0003142. So 50 divided by 0.0003142 will give us 1.95 times 10 raised to power 7. So stress equal to 1.95 times 10 raised to power 7. So what is the unit? First is in Newton. So Newton per, then area is in what? Meter square. So Newton per meter square. So question B. So we are looking for the strain. Strain equal to extension divided by the original length of the wire. Extension divided by the original length of the wire. So extension equal to 0.25 millimeter. So we have to convert this 0.25 millimeter to meter. So therefore E equal to 0.25 divided by 1000 will give us 0.00025 meter. So therefore extension equal to 0.00025 meter, then divided by the original length of the wire equal to 5 meter divided by 5. So which is equal to, so by the time you use 5 to divide 0.00025, it will give you 5 times 10 raised to power minus 5. So meter cancel meter. So therefore there is no unit for strain. No unit.